All right, so today we're going to be talking about dilations around a point that is not the origin. And so we've got some steps that we're going to use, and I'm going to kind of walk you through them, but that's a breakdown of essentially the 5 steps that we want to use. So our first question is asking us to find the coordinates of image ABCD prime with a center of dilation at 1, -2. So I'm going to mark 1, -2 on my graph. That is my center of dilation. And so what we need to do is we need to find the slopes of all 4 points from the center of dilation. So I'm going to start with A. 1, 2, 3, 4, 5, 6 rise. 1, 2, 3, 4. So A is 6/4. For what I'm doing right now, I do not want to reduce these numbers. I just literally want to know what is the rise over run to get to these points. For B, 1, 2, 1, 2, 3, 4. So B is a rise of 4/2. C is a rise of 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. -6/4. And then D is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. So D is 4 rise, a -4 rise, and then 8/. So what I want to do next is I want to multiply each X and Y rise and run by the scale factor. So I'm going to write it this way, but it's not actually multiplying the fractions. And I'm going to explain it here in a second. So what I want to know is, I want to know what is 1/2 of 6. 1/2 of 6 is 3. What is 1/2 of 4? It is 2. So my new slope is going to be 3/2. So I'm going to count from the origin. I'm going to go 2/, and go up 1, 2, 3. And so this right here is now A prime. And so if I were to draw a line, a linear line, it should go through all 3 points. My center of dilation, my A prime, and my A original. So again, 1/2 of 4 is 2. 1/2 of 2 is 1. So my new B point should be at up 2, 1, 2, right 1, which is right there. That should be B prime. Again, I should be able to draw a line through B, B prime, in the dilation, or the center of dilation. 1/2 of -6 is -3. 1/2 of 4 is 2. So for C, we're going to go over 2, down 1, 2, 3. And so that should be C prime. And again, I should be able to draw a straight line and it go through all 3 points. And then D, -4 divided by 2 is -2. 8 divided by 2 is 4. So I should be able to go down 1, 2, left, 1, 2, 3, 4. So again, if we draw that straight line, it should be there. And now that would be D prime. Let me label it on the graph. And if I connect my dots, it's following the same shape pattern, and it is smaller. And so that is how we do dilations about a point. So my new points, A is at -1, 1. B prime is at 2, 0. C prime is at 3, -5. And then D prime is at -3, -4. And so those are my new points. All right, so again, we've got a center of dilation. And the first thing that I want to do is I want to mark that center of dilation on my graph. -3, 1. So this point right here is my center of dilation. So I need to find essentially the rise and run between the points and the center of dilation. So for X, it is a run of 2, so it's a rise of 0. What are you doing in Y? Program, go away. So it's a negative 2 over 0. For Y, it is a over 1, down 1, so it's a negative 1 over 1. And then for Z, it is down 1, 2, 3, 4 over 1, so negative 4 over 1. So this time my scale factor is 2. So I'm going to multiply by 2, multiply by 2, multiply by 2. So 0 times 2 is 0, 2 times 2 is 4. So I'm going to put my new point. So I'm going to go up 0 and go over 2, 3, 4. So this point right here should be X prime. For Y, a negative 1 times 2 is a negative 2. 2 times 1 is 2. So it should be a negative 2, 2. So I'm going to go down 2 over 2, which puts my new Y coordinate right there. And then negative 4 times 2 is a negative 8. 1 times 2 is 2. So I'm going to go over 2, down 2, 3, 4, 5, 6, 7, 8. And this point right here is Z prime. So now I'm going to connect them together. So again, let's trace our lines and make sure that they hit all 3 points. So X is good. Y is good. And finally, Z is good. So they all hit the correct spot. So my new coordinates are X prime is at negative 7, 0. Y prime is at negative 1, negative 1. And Z prime is at negative 1, negative 7. All right, so now we're given our center of dilation, which is negative 2, 1, which is right here. And I'm given my scale factor, so it's 2/3, so it should be a reduction. So to get to M, 1, 2, 3, rise of 3, 1, 2, 3, 4, 5, 6. So we have 3 over 6. For N, we go down 1, 2, 3, 4, 5, 6. Right, 1, 2, 3. So it's a negative 6 over 3. For O, 1, 2, 3, 4, 5, 6. It's a run of 6. But it's a rise of 0. Then finally for P, it is 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. So a rise of 9, a run of 3. So now our scale factor is 2/3. So quick reminder when we're doing fraction multiplication, if I'm multiplying 3 times 2/3, I'm going to go 3 times 2 and divide it by 6. So 3 times 2 is 6. Not by 6, by 3. Oh my goodness, I'm sorry, guys. Divide it by 3 because 2/3. So 2 times 3 is 6. Divided by 3 gets me 2. So I'm going to go up 2 instead of up 3. And then 6 times 2 divided by 3. That is 12 divided by 3, which is 4. So it's going to be 2 over 4. It's going to be where I go. I'm going to start at the origin. 1, 2, 3, 4, 1, 2. So if I put M prime there in a straight line, yep, we are good to go. Okay, a negative 6 times 2 divided by 3 is going to be a negative 4. A positive 3 is 2. And all I'm doing is I'm looking at, I already did 6 and 3 for my other math, so I just need to look and check it. So we're going to go to the right 2 and down 1, 2, 3, 4. So this point right here should be N prime. And if I draw a straight line, yep, it goes through all points. 0 times anything is 0. 6 times 2 is 12. Divided by 3 is 4. So we're just going to go over 1, 2, 3, 4. So this should be my new point. That should be O prime. And again, everything should go in a straight line. And finally, 9 times 2 divided by 3 is 18 divided by 3, which is 6. So I get 6, and then 3, I know the result is 2. So I'm going to go left 2, up 1, 2, 3, 4, 5, 6. This puts me right here, which, yep, everything lines up and is good to go. Put a box around that just to make things nicer and neater. So my new location of M prime is 2, 3. My new location of N prime is 0, 3. My new location of O prime is -6, 1. And my new location of P prime is -4, 7. And so that's how we do dilations not at the origin.